welcome to Unit 4. So we're going to cover three big ideas in this unit. This unit is normal distribution, which we've done before. You should recognize, our distributions here. This isn't anything new. This is stuff like we saw in Unit 2. But the reason we're doing it now, again, is because we just did probabilities. And normal distribution actually has a very close connection with probabilities. So it's a good idea to get an idea of what probabilities are before we start this unit. So this unit has three big ideas in it. First of all, we're going to be finding probabilities based on some information, usually a z-score. And second step, we're going to find z-scores, just like we've done before in Unit 2. And finally, we're going to find some x-values, some data values along that curve. So the big idea here is we're going to have data which is spread out in a normal distribution, a standard normal distribution, which means that most of the data is kind of centered around the mean here, and then there's smaller values, there's larger values, but in general this is the spread of the data. So that could be the heights of males and females, it could be, the production of some tires, where you have, your target size of a tire, and then you have your kind of little bit too small, a little bit too big. It could be IQ scores, could be length of employment, like the length of time. Most people kind of work, I don't know, maybe you work at a job for 15 years, but then you got some people that work for only 10 years or 5 years, or maybe you got people that work for a really, really, really long time. They'd be up by the top. Or even blood glucose. So you have a certain amount of blood glucose level in your body. Most people kind of have the same general amount of blood glucose level, but some are smaller. Some have less blood glucose levels and some have higher. So, long story short, what we're going to be doing, again, is doing three things. Working with probabilities, z-scores, and x-values, and we'll get right into it. So from Unit 2, we already know all this stuff, so it's probably a good idea that you reread this, but the idea is that a distribution with a mean of 0 and a standard deviation of 1 looks like this. So your mean is right in the center, and then you go up and down from that point by your z-value. The z-value represents standard deviations away from the mean. Each increment of 1 responds to 1 standard deviation from the mean. So if it's the z-value is 2, you have 2 standard deviations, 2 standard deviations. The z-value of 3 would be 3 standard deviations. You can go in between. You can have a z-value of like 1.67 if you wanted. There's no reason why not. And that would be where it is. So we've done this before. It says here, suppose you have a normal distribution with a mean of 10, and standard deviation of 20. Well, the big idea here is if you want the z-score, you just take the data value minus the mean, divided by the standard deviation, and you're going to get the z-score. So all that's review. You can read that yourself. But in terms of connecting it to this unit, we have kind of four big ideas about the standard normal distribution. The standard normal distribution is when we're dealing with z-scores, not standard deviation itself. So it's always 1s, 2s, 3s, and things in between. So the first thing you need to know is that total probability always equals 1. You can only have 100% probability of all cases happening, okay? It means that once you add up all the possibilities together, all the data together, there's a 100% chance that all your data lies below the curve, okay? So it says, and this is very important, the total area under the curve is 1. So the total area, also known as the total probability of the data being under the curve, is 1, or 100%. So in more concrete terms, what it means is that if you have a spread of data like this, what's the probability that a data value is going to live in that spread? Well, it's 100%. Your data has to live somewhere. If you're looking at heights of males, maybe this is 170 centimeters or something. Someone might be way down on this side of the curve and have like a height of 50 centimeters. There's still a chance that they're that tall. The probability is just very small. Okay, so anyway, when we talk about probability, it's the likelihood that you're under a certain part of the curve. The second point here is that the curve is symmetrical, which means that the left side is the exact same as the right side. For us, what that means is that half of the area is going to be 0.5. So on the left side of the curve, we always have 50% of the data, which is why we have that 0.5. On the right side of the curve, we also have 50% of the data. that's really important because it means that our data is cut in half on left and right, and it's nice, easy numbers to remember. Our third piece is that the area between z-scores -1 and +1 is equal to 0.68. And this also is nothing new. The reason I'm saying it's not new is because what you should do is remember we had our 68, 95, and 99.7 rule. And that rule told us that between a plus and minus 1 standard deviation, we've got 68%. And between plus and minus 2 standard deviations, we've got 95%. If you go to 3, go between this value and this value, that's your 99.7% of the data. Or in other words, we have a 68% chance of the data living between these two z values. We have a 95% chance of data living between those two z values, and so on. Finally, the area between the z-scores of -2 and +2 is 0.95. Well, I kind of already said that. I guess I jumped the gun on this one. That's really kind of a more accurate. I'll just redraw that. So the idea is that in between your plus and minus z values here, this is 95% of the data, which is important to know if you want to do these short. They take a very short time to do questions that are involved with this. So on the next page, we have some examples and some problems. It's kind of all things that we can do pretty quickly. The first one says, what is the area between z equals 0 and z equals 1? So something that is important to know is that all these questions on this page can be done using the empirical rule. This is from Unit 2. You should be very comfortable with that. So what is the area between a z value of 0 and 1? Well, the z value of 0 is here and the z value of 1 is here. So the area we're talking about is in between. If you remember from Unit 2, that's 34% of the data. Or in other words, 0.34. All right, the next question, what is the probability of data lying below z equals 1? So z equals 1 is right here. It's the probability that we have data lying in this region down here. Now what's the probability, or what's the size of the area under that curve? They mean the same thing. If you remember your rules from Unit 2, you should remember, oh sorry, that's z equals -1. Don't make that mistake. That's z equals 1 right there. So what's the probability of anything lying below that? From our Unit 2 rules, you should remember that half the curve is 50%. And then this little bit here, that's 34% because it's half of 68. So 50% along with our 34%, that's 84% of our data is lying below that point. And it's really important you notice that saying below, because we're going to be dealing with what's called z-tables a little later, and they're going to be talking about all the area at the z-score and below. It's very important that we keep that idea in mind. So we'll do a little more practice here. What's the probability of data lying above a z-score of 1? So what that's talking about here is above a z-score of 1. This is our z-score of 1. All the area, or the probability that data is going to lie there. So what's the area under that curve, or the probability that data will lie in that region? So see if you can get that. That answer is 0.16. I'll put the answers up in a second. But for the second one here, we have probability of the area between z equals -2 and z equals -1. So that's this one. So again, pause the video, see if you can puzzle that out based on what you know from Unit 2, and I'll give you the answer. Okay, hopefully you paused it. Now what we have is, in this case, there's two ways to figure out that region. You can know that we have 50% of the data, oops, no, not 50% of the data. We know that this region here, hopefully you remember this region here is 13.5% plus 2.5%. So the total amount of data in that area is 16%. That's one way to get it, 0.16. It's from our empirical rule. Another way to get this is to say, well, you know how much data this is, because that would be 50% of the data and 34% of the data. You know, you've got all that data, which adds up to 84%, but you want what's above that. You don't want this region, you want what's above that region, so you take it away from 100, which would give us 16%. So a couple different ways of accomplishing the same thing here. Take some time to review that and see if it makes sense. In this case, we're going to need to take two values and subtract them, or the easier way to do it would just be to know how much of the area is in that region. And if you remember from Unit 2, this is 13.5%. So you can just get 13.5% directly, which is the same as 0.135. The reason I'm writing them as decimals is that's just standard for probabilities, but it's up to you which one you want to use. If you're doing the assignments and they're multiple choice, for example, you just need to be able to change them between percentages and decimals. So I'd like to show you another way to accomplish these types of questions, which is using a calculator, an Excel calculator. So in your course shell here in 1530, if you go into content, under calculators, Unit 4, you can find probability calculator for students, or if you go into Unit 4 here and go beneath the notes here, probability calculator for students, I recommend that you go ahead and download that. And when you download that and open it, what you're going to find is something that looks like this. Okay, so this is a calculator that was made by Laura Anstey, actually, and it can help us solve these problems that we just saw. So first things first, what is the probability of data lying above a z-score? So if you're looking for probability and you're given a z-score, this is what you do. Find the normal distribution, you've got your z given, z-score, probability that a z-score is less than a certain value. So what's our question? Our question is probability lying above 1. So probability that the z-score is greater than 1 is going to be 0.159. We've got 0.16, so 0.159 is correct. What's the probability of the z-score being between -2 and -1? Basically, it's just saying, you know, if you've got a z-score of -2 and -1, what's the probability that we could have data in between these 2 points? And the way that we talk about this is we say, what's the probability of the z-score being between those two values? So between -2 and 1, probability that the z-score is between -2 and -1 is 0.136, which our answer is 0.135. That's the same thing. Our empirical rule rounds our answers, but the calculator doesn't round as much, it keeps more decimals. There is one other way that we can calculate these or check our work, and that is using online calculators. So if you go to, let's find it here, the D2L shell, I've linked in calculators to a z-score calculator. If you open up that website, this is what you'll find, and you can look around and see what you're looking for. For z-scores and calculating probabilities, we're looking for the probability of below a z value and above a z value, or between z values. Okay, so for example, the question I just did, the probability of being less than a certain z value, so above 1, you can use this calculator, probability of being, take that, above z, above 1, the probability, given that the, oops, I need to put my z-score in. The z-score is 1. Calculate. It'll actually give us all the things. This means that the probability of being less than z is 84%. You can see it's that region here. We don't want that. We want the probability of being greater than z, which is up here. So that's 0.15866, which is very close to our 0.16. So we know that this is okay. All right, so I'm going to come back to this calculator later, but for now, this is enough. So the next thing that we need to do is learn how to use the z-table, use what's called a z-table, to determine probabilities for a standard normal distribution. So we just did this. We just determined probabilities using really, really simple numbers, but they were all whole numbers. You'll notice it's like 2s, 1s, 0s, things like that. Z values are usually all sorts of different numbers. So what it's saying here is the important concepts we're familiar with are probability, z-score, which is a version of the standard deviation, and x-values, which are the data values. So maybe you have a blood glucose level of 100 and the standard, the mean is 90. What would be the z-value for that? Or what's the data value? And you need to know what these concepts are, but we dealt with them already in Unit 2. So sometimes we only know one or two of the pieces of information. For example, we might know a z-score. We know a z-score, and we want to find probability of the data lying above or below that point. So you might know a z-score, and you want to know what's the probability, what's the probability of the data lying below that point. So that z-score is not a data value, that is a standard deviation value. It's how many standard deviations you are away from the mean, so that's important to know. So we're going to do that in kind of three ways really. The first way we're going to do by hand using a table. The second way we're going to use Excel, and there's a third way we're just going to use z-score calculators. Okay, so I'm going to leave it up to you in a lot of cases as to which one you use. You need to be able to use the z-table because if we're to do a test on this on campus, we might not be able to use computers, right? So in the absence of being able to use a computer or your phone, you need to be able to go to the z-table. But for the purposes of learning it, we can use the calculators. So first things first, by hand, how to use the z-table. So let's just suppose that we have a data entry which has a z-score of 1.27. Okay, so our z-score is 1.27, and the question is, what is the probability that a randomly selected piece of data will fall below that point? So basically, you can think of it like this: you've got your z-score of 1.27 here, and what's the probability that it's going to fall below? So it's going to be above 50%. The way we use a z-table is as follows. You look at the first two numbers, that'll give you your decimal, 1.2. So you'll look at the leftmost column of the z, look for 1.2. The decimal here, 7, you'll look along this column here. Okay, that'll give you your hundredths point. So this point here, 0.7. If you have your z-score, you look at where those two things intersect. So you'll look down this way and look down this way. And the answer that it gives you is the probability of data lying below that z-score. And it is very important. It's the area to the left. Okay? It's the area to the left of the z-score. So if the z-score is 1.27, then the area below that z-score is going to be 0.89796. And that means that the probability is 0.89796. Now that's using our z-score to figure out this question. Let's see if we can use our calculator to also figure out this question. If you're using the Excel calculator, you can use this page. Probability that a z-score is less than, 1.27? Probability 0.898. Our answer was 0.897, which rounds up to 898, so we're good. Let's see if we were to use the online calculator. If the z-score is 1.27, click calculate. You need to be able to read these, okay? This is the probability that your data value is below the z-score. This means less than, this means greater than. Below the z-score, 0.89796. That is exactly the same as what I was saying in my notes. That's the score that it gives me from the table. So I know that this calculator is pretty reliable. Our second example on this page is, what is the area to the right of z equals 1.27? In other words, what is the probability that our z value is above 1.27? So what it means is, if we have this little diagram, we know our 1.27 is about here. What's the probability that our z-score or a piece of data could lie above that point? What's the area of the curve above that z-score? Or what's the z-score? What's the probability above that point? So all we need to do in this case, we know that the probability of z being below 1.27 is 0.89796. If the probability of it being below is this, then the probability of above we just take away from 1. So 1 minus 0.89716 equals this. And the logic for this is that you got to remember that this whole curve adds up to 100. So this red piece, it's kind of like our mystery red piece plus our 0.89796 has to add up to 100, or add up to 1, in other words. So that means that x must just be 1 minus the area to the left. So if you have the area to the left, it's easy to get the area to the right. You just subtract it from 100. So that's how we're going to do these questions. I'm also going to check this on the calculator. So the area to the right of 1.27, the probability that a z-score is greater than 1.27 is 0.102. And in my case, 0.10204. That sounds right. I'll check it on my online calculator as well. Calculator, I've already done it. The probability that a data score is above the z-score given, 0.10204. And it's very visual. It's this z value here and above. All right, and these change based on what you put in. So if I put in a z-score of like 2.8, which is actually a really big z-score, you can see it's this tiny little area above and most of the data is below. And if you understand your z-scores, that should actually make a lot of sense to you. 3 z-scores away, or 3 standard deviations away, is a huge distance away from the mean. So how to use a z-table? Well, these z-tables are given on D2L, okay? I've given them to you. If you want to find them, go into your table of contents or just content, and in Unit 2, Appendix 1 is the z-table. So your z-table is given here. You can download this. It teaches you or reminds you how to use it, but really it's the last 2 pages that you want. These are the z-scores that are negative, and the next page are the z-scores that are positive. So this is what we would use to solve for our answers. And it's important that you make a note of this. If the z-score that you're given is not in the table, just use the closest z-score. What that means is if you're given like a z-score of 1.278, that's not in the table, so you just round to 1.28 and look for that instead. Positive z values, same story. You can see that it's this side of the curve, all of these z values here. Same story. So the questions are going to be like this. You're going to want to determine each of the following areas or probabilities using the z-table. So this is the probability that the z-score is below 1.25. All right, so it's pretty helpful to draw a little picture. 1.25 is about here. So the probability that we're lying below that region, it's all this. So it's definitely greater than 50%. You just need to figure out what. And the way you do it is very simple. You've got 2 options, right? You can use a calculator, or you can use the Excel, you can do it by hand. So the probability, I just like to do it shorthand, probability at the z-score of 1.25, I just assume this is the area to the left of that point, is going to be, if you use your table, 0.89435. And I want to show you how you'd figure that out. So I've got the table put in here, and it's a positive z value. If you're looking at the notes right now, sorry, it's just loading up. If you're looking at the notes right now, you can see that the z value is 1.25. So how you do this is you look for 1.2, you look for 0.05, and the reason for that is 1.2 plus 0.05 makes our 1.25 z-score that we're looking for. And these 2 things come together to give 0.89435, which is exactly what I had when I did my notes. 0.89435. If you wanted to use your Excel calculator, just put 1.25 in. Z-score is less than that, 0.894. 0.894, that's the same. And again, you can do it online. 1.25. You want the area to the left of it, so you look at the region to the left of the value, 0.89435. All right, so this is how these questions go. The only difference, there's, I guess, 3 cases. You can have the area below. Let me write these down. You have 3 cases when you're looking for probabilities. First, the area below. Second, the area above. And the third, the area between Z values. So we'll do some more examples. The first question is below, the second question is below. I'll put up the answer for that one after, at the end of the section. I'll put up all the answers. 3 I'd like to do. What you'll see here is that the probability of the Z value lying above 0. Okay? So the question is, what's the probability that your data is going to lie above this point? Well, if you're paying attention, you actually don't need the table for this, because we know this. The probability of lying above that point is 50%. Because every time you deal with half the area, you're dealing with 50% of the area. You don't need a table for this. But if you want to use a calculator, all you need to do is put in 0.5. Sorry, put in 0. The probability of being above that point is 0.5. So that's all there is to it there. And all of these can be done in a similar way using the calculator or using the table. I'll do number 4 with you, just because it's a little bit tricky. You can see that it's greater than, once again. I'm going to say careful. And make a note of this. The table gives the values to the left. Alright, so what that means is if you had a Z value of negative 2.16, you need to go 1, 2, and a little bit. So this is negative 2.16 below the mean. The table gives you the values on this side. That's not what we want. We want the values to the right. Okay, we want the area to the right. And that's very important because we'll need to get the value from the table and then subtract it from 1. So let me show you what this looks like. First things first, just treat it like a normal problem. The probability of being below this point, if you use our table, I'll show you how to use the table, negative 2.16. Let's go ahead, look in the table, the negative table. Negative 2.16, negative 2.16. The probability of being below that point is 0.01539. That should make sense because that's really small. And this is a very small region. So if that is 0.01539, the answer is actually 1 minus that. And so it's 98461. Just going to double check that I didn't write that wrong. Yeah, 98461. Which, if you understand this, makes sense. Look how much area is above that point. Almost all of it. In fact, 98% of it. And so it shouldn't be too much of a surprise. We can get this value from the calculator as well. So if the x value is negative 2.16, calculate. You want the area above it. The area above it is 0.98461. Okay? So I'm going to do one more of these, and then I'll leave the others for you to try. I just want to show you how you would tackle one that's between. Okay, So this is between two z values. What I would do first is I would sketch them. So negative 1.5 is around here. 1.25 is around here. And you want to go between those two values, all right? So we're going to be dealing with the area in between them, which is this big. So it's going to be a little bit bigger than 68% because it's more than one standard deviation away. And the way that I would do this is think of it as the area below this point subtracting the area below this point. Okay? So you take the bigger value, subtract the smaller value. Or in other words, you take the probability all the way up to 1.25. That would be all of this region here. And subtract the probability below this point. All right, and it'll kind of take away that area. So the probability of the bigger one, subtract the probability of the smaller one, or the smaller area will leave you what's left, okay? So if you look those two values up in the table, you get this. I recommend you check that. 6681. And if you solve that out, you get 0.82754. Which makes sense. 0.827, about 83% of your data lies in this region. That checks out. That's a pretty big area, so that's not a big surprise. We can check it in two ways, 1.25 and negative 1.5. The z-score between negative 1.5, the smaller one, and 1.25, 0.828. That checks out. It's almost exactly what I got. And then in this calculator, you're going to want to do the probability between two z-scores. It says like a probability like this. The leftmost one was negative 1.5. The rightmost one is 1.25. Calculate that. The area is this, 0.82754, which is exactly what I have in this case. All right, so I recommend that you try the questions that I've skipped. I'm going to put the solutions up now. I've also got the answers posted online, and you can check your work against that. So just bear with me here, I'll paste them in. Okay, so this is our answer for 2. You can pause the video and try that question yourself, or just write down the answer for later. And the answer for 6, between 0 and 2.86, this is what you would get. Let's move on to another type of practice question. These questions I'm not going to do fully. I'm going to do some of them, but I won't use the table for all of them. I'll use a calculator. So the results for MA1530 over the past 5 years indicate that the final exam marks are normally distributed with a mean of 75. So that's good to know. And a standard deviation of 7. Based on this information, what is the probability that a randomly selected student who completed this course over the past 5 years received a final exam mark less than 65? So in this case, we're looking for a probability that the value is less than 65. So I'm actually not going to write anything there yet. We'll talk about how we're kind of missing some information. So normally we want to find the probability less than a z-score. But what we have here is not a z-score. It's a data value. So we can't put it on this diagram. So let's just remember what we did in Unit 2. So if I was to label this like Unit 2, this would be 75. One standard deviation up is that plus 7. So 82, then we get 89, and then we get 96. If we do the other side, subtracting 7 each time, which is the standard deviation, we get these values. These are not z values. The z values would be 0, 1, 2, 3, negative 1, negative 2, and negative 3. So we want to get the z-score, and if we get the z-score, we can then get the probability. So just try to follow me on this one. Less than 61, if our x value, our data value is 61, that lives over here. which means that our z value is going to be -2. But let me show you that in a clearer way. Let's remember, if we're looking for z-scores, all we need to do is x minus the mean over the standard deviation. Or we can have our x value, 61, subtract the mean, 75, divided by the standard deviation, 7. What you'll get is -2, which is no surprise, really. That's what we expected. But if you want like a method to do it, that's how you do it. So we found the z-score using the formula. There's a little typo here I just caught. Maybe you didn't even notice. Find the z-score for 61 using the formula. The second step is we're going to use that z-score with the z-table to find probability. Or in other words, I already know now the z-score. I want the probability of being less than that point. So in my diagram here, it's just the probability of being less than that point. All right, what's the probability of getting a mark less than 61 based on our previous data? So I'll just say the probability for, the z-score being less than -2 would be what? Well, use your table and you'll find that it's 0.02275. All right? That's all you need to worry about. If you want to check it on a calculator, you can check it on an online calculator. The probability of being less than a z-score of -2, sorry. If the x value is less than that, 0.02275. Same thing. So you'll see this in different ways. Try not to get too confused. It can be written also the probability that your, x is less than your z-score, the probability that your data value is less than your z-score, or the probability that, in this case, 61 is less than your z-score. But I find that it can be a little bit confusing. So in many cases, what I'll write is just the probability at -2. Basically, the probability, or the area of the curve, up to a z value of -2, which is just this. I feel like that's the clearest way to do it. There's all sorts of different ways to write this down, but I feel personally that that's the better way to do it. Okay. So above 82 is done in almost the exact same way. We just need to take it away from 1. All right. So try this question. I would recommend that you see if you can get this answer. And if you can't, well, you can watch this video now and I'll post the solution for it. So this is how I did it. I used my data value, found its z-score. Once I had its z-score, I can just find the probability that I would lie above it. Remember that the z table would give you this area below, which is 0.84134, and you have to take it away from 100 and you get the above. So the big takeaway is that whenever you have above a z value, remember to subtract from 1. That's kind of the big trick here, okay? Just be careful. I also said here, use the empirical rule. And the reason I said that is because if you remember your rules, you'll know that this is 34%, you'll know that this is 13.5%, and you'll know that anything above that is 2.5%. All right? These two numbers added together give you 16%, which is very, very, very close to the answer that we got, which is why we can check with the empirical rule. It's actually the same thing because our z value was simple. But I wouldn't rely on that because you might get confused, okay? So finally here, what's the probability of getting between 70 and 85? First I'm going to just paste the method here, and I'll talk through it and then I'll show you how to do it on the calculator. So in this question, it's the probability of the data being between 70 and 85. So the first thing we needed to know, this first of all, is these are data values, they're not z-scores. So convert them both to z-scores. All right, we want the probability between those two z-scores. First z-score is going to be found this way. Second z-score is going to be found this way. That's by the formulas, okay? This gives you a value of -0.71. The other one gives you a value of 1.43. I'm going to sketch those on the diagram here. And what I'm looking for is the area between those 2 points. That's pretty easy. Take the probability up to the bigger one, take away the smaller one, and it'll leave you the area in between. So subtract the probabilities. what you end up with is this. What takes the most time probably is using a table or a calculator to put those in. So let me just show you how you would use the calculator to put these in. 1.43 and negative 0.71. So if you're using the Excel one, let's see, I don't know if this one has the two values. Oh yes, it does. So this calculator, thankfully, can be done for any value. So this question, it said that the mean was 75 and the standard deviation was 7. What's the probability that an x value is between, in our case, 70 and 85? The answer should be 0.686, which is almost exactly what I have. Sometimes using the Excel calculator, you'll be off by a decimal or so. You can see that there's a couple different differences here. But this is the essence, okay? This is close enough. If you're doing it online with the online calculator, you want the probability between the two z-scores. You need to get the z-scores first. So we did that, negative 0.71 and 1.43. If you calculate this, it'll give you the answer that you're looking for, 0.8479. So lots to keep in mind. Remember, there's kind of three ways to do this. You can do it by hand, you can do it using the z-tables, which I didn't show you for this question, and you can do it by the calculator. At the end of the day, the most important piece of information that I think you can take away, or sorry, the most important thing you can take away, is your understanding of the questions. So remember, we're doing the same thing every time. Given a z-score, we're looking for the probability of the data lying before that z-score, above that z-score, or between two z-scores. The next page here is practice. It's done almost the exact same way as the questions that I just did. So I'm just going to put the answers here, and you can try the questions on your own time. So these are the answers for the questions in question 2. Notice I made a small mistake on this. I think I fixed it in the notes that you have. And you'll see that I was given mean and standard deviation. If you're given that, you need to find the z-score first, and then your data value is given, find your probability. It'll make more sense when you try this question yourself, okay? One thing I want to be very clear about is that if you have questions on any of this, especially because it's pre-recorded, please just send me an email. I don't mind going through any of this with you. We can take 10 minutes. We can set up a little meeting. I can go through anything that you need. Even if you want to take an hour, I don't mind. But I'll go through whatever you have questions on, and then hopefully things will be more clear and we can move on. 3, this is the answer. You can also check the answer key on D2L. So our next step, which is kind of the only step left really in a lot of ways, is going backwards. First we have gone, let me just draw you a little diagram, I guess. So what we were dealing with just then is we were going from z values to probabilities. This would be kind of like our forward direction, okay? What we often will find in this unit is that you'll have your probability. I guess I could just use this. You'll have your probability and you want your z-score. That's going backward. So sometimes we know the probability of getting a value, but we don't know what the z value is. So it's really important that we can work backwards. And the steps we're going to take are as follows. When you're asked to find a value of x, and you're given a probability, or if you're, if you're asked to find the z value either, same idea, use the given information to find the z value first, and then use the z value to calculate the x value. So remember, if we have the z value, we can find the x value, and if we have the probability, we can find the z value. It'll make more sense once we actually do the questions. So these are some tips for solving for the x value. First of all, shade the indicated area to help you figure out the location of the x values in relation to the mean. So for example, greater than, which for example might mean this symbol, means shade the area to the right. Less than, which means this symbol, means shade the area to the left. So if we had a z value like this, greater than is shading the area to the right, less than is shading the area to the left, okay? Use the given area or probability to figure out the corresponding z value using the table. Careful, the given probability is not always the number you'll use with the table. That means that sometimes we have to round. I have a feeling that you'll want to use the calculators anyway, so the table won't cause you too much trouble. If you want to use the table, it's there for you, but in many cases the calculators online or in Excel are more than enough. Z-scores to the left of the mean are negative. This is kind of your negative region. This is your positive region, okay, if we're talking about left and right of the distribution. In some cases, the given area or probability will not be found in the table. Use the entry closest to it. You know, these are kind of the same point. If the given area is halfway between two areas, use the z-score halfway between the corresponding z-scores. That almost never comes up. And then solve for x values using this z-score formula. All right, so you could have read that yourself and saved you some time, but I read it for you just in case you wanted to hear me talk about it. But this is very important. What it means is that if you're given the mean, the z-score, and the standard deviation, we can find the x value quite easily. Almost there we go. There we go. So, examples. Finding z-score. Find the z-score that corresponds to the given probability. So, there's a lot going on here. It might be a little bit confusing to understand what this means. And what it means is we want the area to the left of a certain z-score. Now, let's be very clear. We're looking for the z-score. We don't have a z-score, so a lot of students make the mistake of putting this in as a z-score. It's not a z-score. What it is the probability of a piece of data lying beneath that point. Okay, so what we have, the area, or the probability, is 0.0250. Right? It's important to note that we don't have a z-score, we have a probability. We're going to use the z table to find z, or a calculator. So we need to find z. So you can use a table or a calculator. And just to save some time, it's COVID after all, let's just use the calculator. Okay? So the probability at a certain z-score is going to be 0.0250. All right, that means that our z-score can be found using our calculator. Let's see if we can figure it out. So our probability is 0.0250. So let's look through. Normal distribution. We want to find z-score? No, we don't. We want to find, this is if we're given a z-score. So we don't want that. What if you're given, you want to find a z-score given a probability? Yeah, that's what we want. What were we given? We were given the probability of the data lying below the z-score is 0.0250. So the probability or area to the left of the z-score, 0.0250, the probability, that z-score corresponds to negative 1.96. Let me try to clarify what we just did. There's not a lot to it except for the thinking. The calculations are very short. What takes the most time is the thinking. So negative 1 and negative 2. So negative 1.96 would be right here. So the area to the left of that would be very small. In this case, 0.0250. Or 2.5%. Okay, so what we were doing, what we did, we knew the probability to begin with. We had to work backwards from that to find the z-score that corresponds to it. You can use the calculator to do that. Let's look online and see if our calculator can do it. Z-score and probability, please provide a value. So we don't know the z-score, get out of that. But the probability of a data value lying below a z-score, well, we know that. We know the probability is 0.025. So if we put that calculation in, it says, given that the probability of our data value lying below a given z-score is 0.025, the z-score must be negative 1.96, which is exactly what we know it has to be, because we just did it in a different way. So it should make sense. And what I like about this calculator is that if you give it the probability, it'll actually spit out all the different probabilities. It'll give you the probability above that point, probability below, probability between. There's lots of data here, but this is the value that we want in z-score. All right, so that's how these questions are done. The only really other trick, in a way, is if it's above. So here we have z-score greater than a certain value. This is the area to the right of a mystery z-score. And we're asked to find the z-score. We have the probability, we need to find the z-score. So let me be clear here. If we want the area to the right, if the area to the right is 0.2389, then the area to the left is 1 minus this, or 0.7611. And the reason that's important is because if you're going to use the table, this is the value that you need for the z-score. Sorry, for the probability. So the probability of that z-score is 0.7611, which means that the z-score is going to be 0.71. Now, I know that z-score because I calculated it beforehand. Let me show you how I would get it. I'm going to show you how to use the table for this time. So, let's be clear. I just figured out the area to the left of some mysterious z-score. It's 0.7611. So I can look in my table. I need to look at my positives. I'm looking, this is a table of areas and probabilities, okay? So I'm looking for, let's get rid of this, 0.7611. I'm actually looking in the table for a probability that's very close to that. And what I find is 767676. This one. This is a probability. All right, this is a probability, and what it's going to give me back is my z-score. You can read it off. 0.71. So my z-score is 0.71. Now that takes a bit of work to get to, doesn't it? But that's how we do it. And if you want to make a picture of what's going on here, 0.71 is what I'm dealing with. The probability below that point, the area to the right of that point, 0.2389. The area or probability to the left of that point, 0.7611, which hopefully should make sense. I'm to the right of the mean in this case, which means that the probability got to be greater than 50%. It all kind of checks out. Now, one last thing, I'll put this into the calculator online so you can see how this is done. So the probability is 0.2389. Probability above, okay? Probability above a certain z value is what was given. So 0.2389. Z-score is 0.71. It's exactly the same thing as I said it was. Now, I want to make some things clear. This is saying the probability of some data lying above the z-score, that we don't know the z-score, is 23.89%. That much. What I did in my first step in the notes was I took it away from 100, and I got my 7611. That would be the probability of lying below that point. And the z-score at those 2 points are exactly the same. No matter what way you do it is 0.71. So I can't stress this enough. Get the practice. Okay, spend time working through this. Use the table, or probably better, use the calculators, and make some sense of this. And if you have trouble, you just can't get some of these answers, I'd really like it if you let me know so that I can review it with you. But once this stuff clicks, these questions don't take a long time to do. So I'm going to put the full solutions online for these, but I just want you to know that you should be trying these yourself. So try these on your own. These are the answers that you should get. This is the probability of being above a certain Z value. This is the probability of being below. Compare that to what I did in the previous questions, okay? Check the answer key for those if you want to know how I got those numbers. The last topic in this unit is to find X values. So we're finding X values given probabilities. So let me be clear here. Let me make a little side note here. If you have a Z-score, they can give you probabilities. Did I spell that right? Probabilities? Yes, I did. Okay. We know that for sure. And if you have probabilities, maybe I'll make a little side note like that. And if you have probabilities, you can find Z-scores. So the other thing is if you have Z-scores, you can find X values, which are data values. Okay? So this is kind of how this stuff works. If you have a Z-score to begin with, and you have your mean and your standard deviation, you can get your X value directly. If you only have your probability, you have to go and get your Z-score first, and then get your X values. We have just dealt with how to get Z-scores and how to get probabilities. So it shouldn't be any problem to get our X values. You might be wondering, well, how the heck am I going to get the X value? The nice thing about it is that there's a simple formula for it. We've done it before. It's the mean plus the Z-score times the standard deviation. In other words, if you have your mean and you have a Z-score and you have a standard deviation, you just take the mean, add this product, and you'll have your X value, okay, your data value. So let's do an example of this. And again, you should really go and make sure you understand all of the stuff up until this point before you try these questions, because otherwise you're just going to get confused. So I made a little mistake when I was making the notes here. This question 1 is the same as question 2 on the next page. So I'm actually going to just skip over that question on page 1, so I have everything on one page here. Okay, so in other words, this is not a different question. Maybe you can use that space for practice later. But what we're dealing with here is trying to find X values, okay? So given a normal distribution with a mean of 40, a standard deviation of 6, find the value of X, or find the X value. So really at the end of the day here, we're looking for X values, given that it has 55% of the area to its right. Okay, so it's very important to understand what this means. I can't be more... I'm trying to be very clear that you got to understand the questions, or else you're just going to get all these concepts confused, all right? There's only 3 concepts, Z-score, probability, and X values, but if you get them all jumbled in your head, you really can't do these questions, all right? It's a short unit, but there's a lot of stuff to it, which is why, even though this video will only end up being a little over an hour, I'm giving you 3 hours to process it. So, 55% of the area to its right. Half of this probability distribution, this is 50%, which means that 55% is probably about, I don't know, let's say this much. So I'm just drawing a sketch here. At this point, we don't know what the Z value is, but we do know that this is 55%. Or in other words, 0.55. We know the probability, we know the area The area is 0.55. So if we can get the z-score, we can then get the x value because we have the mean and the standard deviation and we have a formula for finding x values. We knew it in Unit 2. So there's a two-step process for these questions. First things first is get the z-score using the probability. You can use the table for it. You can take this value, subtract it from 1, go find that probability in the table, and give me the z value. I'm going to allow you to use the calculator, okay? The probability, that's some mysterious z value we know is going to be 0.55. Just to make life easier here, I'm going to say 0.45 because it matches up with the table. Okay, this area is 0.45. Just take it away from 1. So the probability up to this z value, so this area here, right, is 0.45. Just use a calculator to find that. So let's see. We've got to be very careful that we're doing the right thing. Okay, probability or area to the left. So it's asking for an area. Are we given an area here? Yes, we are. We're given an area. We're given 55% of the area to its right. Okay, so the probability or area to the right is 0.55, gives a z-score of negative 0.126. So that's the first step, is to find the z value that relates to it. And that makes sense. This is below the mean, which means it's a little bit below 0, which is why it's negative 0.126. If I use the online calculator for this, let's be really careful. What are we looking for here? We've been given, the probability to the right of a z value. So the probability of some data value lying above some mysterious z value is 0.55. Calculate that, it says my z value is negative 0.126, which is exactly what I have. Okay? All good. Now, the second point, I've got my z-score, but I wanted the x value, so I'm going to calculate the x value. How I do that is using the formula. It's the mean plus the z value times the standard deviation, which is in this case 40, I was given that above, plus the z value, which I just calculated, multiplied by the standard deviation, which is 6. And if you work that out, what you should get is 39.2. Which a lot of students will take that and they're just done, right? But that's not really the way you should think about these things. You should at least take a moment to understand what the heck you just solved. So let's do that. I'll take that moment right now. If your mean is 40, it means that your value right here is 40. Okay? So your mean there is 40. If your standard deviation is 6, it means that you can go up and down by that. That's the amount of spread. So our data value of 39.2 is slightly below the mean. Our mean is 40, our x value is 39.2. So it's just a tiny bit below the mean, which is why our z value is so close to 0. It's only a tiny bit below 0. There is, I believe, one more way to use this Excel calculator. So we're looking for x values, right? Let me see. Normal distribution. What's the mean? What's the standard deviation? What's the probability that an x value is less than 40? 60, that's not what I want. What is the mean of the distribution? What is the standard deviation? Haha. So in this case, in my question, I was given a mean of 40. My standard deviation was 6. The probability or area to the left, I wasn't given that, I was given the area to the right. But if you remember from the question, the probability to the left I figured out is 45. This will give you the value that we want, 39.2. So there's another way to do this, right? You should get very comfortable with this calculator. Spend a lot of time in there trying to figure it out. I guarantee that it's going to make your life easier once you get there. Right now, I know it's probably confusing, but that's what the practice is for. Try every single one of these questions again on your own time, and I guarantee you're going to get better at it. So many ways to do this, but the concept is always the same. Remember what I said earlier. You have, where is it? Yeah, you've got your z-scores, you've got your probabilities, you've got your x-values. What I just did is I took a probability, calculated a z-score from it, and then spit out an x-value because I had my mean and my standard deviation. Okay, so that's how these go. I'll do one more question for you, and then the rest I'm going to just allow you to try in your own time. So 1, I'm going to get the z-score. So this is 45% of the areas to its left. It's the same mean and standard deviation. So the mean is still 40, and the standard deviation is still 6. 45% of the area to its left, well, I kind of already did this question, didn't I? You want the probability of some mysterious z value to be 0.45, because we have 45% of the area is about here. We want to know what that z value is, because if we have the z value, we can find the x value. If the probability below that point is 0.45, then use a calculator to figure out what the z value itself is. It's negative 0.13. I know that because it's the same as the question before, but not every student would see that. So that's our z value. The second step is always to calculate the x value. And we use that using the formula. So the x is the mean plus our z value, negative 0.13. This I took from the table. I didn't use a calculator for this. I found it from the table. You can also get negative 0.126. And then times the standard deviation, which is 6. So the x value in this case, 39.2. It's the exact same thing. The reason we get the same x value is 55% of the area to the right of a value is the exact same thing as 45% of the area to the left of a value. All right? So the answers for these two practice questions are online right now. They're on D2L. There was a small mistake in the notes. This is 33.5. I know it's written there. Some of you, the reason I'm writing over this, I know it says the same thing. Some of you, if you printed these notes early, there was a mistake in the answer here. So I'm just making sure that you catch that. These are the same questions. Just be really careful. This is to its right. So remember, it's going to be to the right side. If you use the table, you got to take it away from 100. What it means is that it's 55% is to its left. And then in the other question, you've got it to its left. It's perfectly fine. You can just do it as normal. All right, and the answers are given online. So the other questions in the notes are exactly the same. It's just a word problem. So I'm not going to do the problem for you. I'd like you to try it yourself, but it's important that you at least try it, okay? So the lengths of time employees have worked at a company are normally distributed with a mean of 11.2, a standard deviation of 2.1. During cutbacks, those with the least seniority are laid off. If 10% of the employees lose their jobs, what is the maximum amount of time an employee could have worked with the company and still be laid off? So 10% of the employees lose their job, and the employees with the least seniority are the ones that are laid off. So that's the bottom 10%. The bottom 10% is cut. What time, like time of employment, relates to an area of 10%. So this is the idea that we're going with. What time are we looking for that relates to the bottom 10%? So it's going to be around here. This is our 10%, or 0.1. So again, we're going to look for the z value at this point. We're going to look for the x value at that point. So the first step is going to be find z. And the second step is going to be find the x. So now you've got the setup. That should be relatively easy to figure out. The answer is going to be 8.51 years, which you can see the full solution online on D2L right now. The last question, practice. Doctors often monitor their patients' blood glucose levels. It's known that for blood glucose levels, the mean is 85. So once again, the mean is going to be 85. The standard deviation is 25. Patients are considered to be high risk for diabetes if their blood glucose test comes back in the top 10% of all results. What blood glucose level marks the start of the top 1%? So you're looking for an X value relating to the top 1%. So you want to know what data value would be above 99% of the other information. So I just want to make a note here. The top 1% has the same Z value and accompanying X value as the bottom 99%. So what I mean by this is like right along here somewhere probably. This is going to be your Z value you're looking for. You also need to find the X value at that point. We know that 99%, the top 1% is this little tiny region down here. So there's 1% of the data is above that point. And in this region, this is 99% of your data. So using that information, you can find the Z value. So the first thing would be to find Z. And the second thing would be to calculate X. And the answer is going to be 143.25. So I'm leaving quite a lot for you to figure out on your own because it's important that you get the practice. But I'm going to remind you one last time, I would like you to let me know if you need extra help because I don't mind setting time aside, especially because we're not having class time this week. So get acquainted with the notes, figure out how to use the calculator online to help you out. Use the Excel calculator to the best of its ability if you like. There's lots of information in here. It's important that you get acquainted with it. And that's really it. That's the entire unit. Only 13 pages, but a lot of content in there, okay? So good luck with it. Take your time going through it, and let me know if you have any questions. All right, have a great day.